Okay, so we've been talking about resources of Latin America, and we started off with the Native American cultures and how they used metals, and then how excited the Spanish got when they found there was so much silver in the region. And then after the Spanish left, North Americans, in particular Europeans, came in and started exploiting other resources that the Spanish hadn't really cared about. And very important one of those was copper. And copper was because increasingly the world was electrifying, and copper is needed for wires and things like that, things the Spanish never cared about. And so electricity is the big future important thing. And with the growing population and rising incomes, it's increasingly difficult to keep our use of fossil fuels down. And so there's an increasing emphasis on renewable resources. And today we're going to talk about one, geothermal energy. So we're talking about geothermal energy, and geothermal energy is needed to make electricity. So we have to talk a little bit about electricity. So the standard unit of power of electrical, well, of all kinds of power, but especially electrical, is the watt, which is named after James Watt. And that's equal to 1 joule per second, or the amount of power that's delivered to an electrical circuit when a current of 1 amp flows through the component and a voltage of 1 volt exists across it. So that's the definition. You don't have to memorize that, but we'll be talking about watts a lot. So the generation of electricity is usually reported in kilowatts, which are thousands of watts, this way, little k, big W. Megawatts, which is millions of watts, big M, big W. Or terawatts, which is trillions of watts, or TW, like that. So Latin American economies require electricity to power their homes and industries. So here you can see the growth of the electrical use in Latin America up through 2015. And you can see what's producing that electricity. A little bit of coal, fair amount of oil, fair amount of natural gas, lots of hydroelectric, a little bit of nuclear, biofuel waste, and increasingly geothermal energy. But by comparison to this, which is about 1,200 terawatt hours for all of Latin America, Texas uses about 365 terawatt hours per year. So let's watch a 5.3 minute video, but we're only going to watch the first 2.5 minutes.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you've probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, Natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states.
I hope you enjoyed that. Here's how I think about electricity. Here in Texas, we have a nuclear power plant just southwest of town. It's called Comanche Peak. So those of you that know where Glen Rose is know where it is, about 60 miles southwest of us. And it has 2 reactor units, which you can see here. Unit 1 generates 1,218 megawatts, and Unit 2 generates 1,207 megawatts. So, okay, numbers, words. Let's think about it this way. How many 60-watt light bulbs, there's a 60-watt light bulb, can Comanche Peak Unit 1 light at any one time? So here we've got how many watts it generates, and each light bulb takes 60 watts. So 1,218,218,000,000, et cetera, divided by 60 equals about 2 million. About 2 million light bulbs. So a lot of, as you saw, a lot of electricity is generated by burning fossil fuels. And okay, that's a way to do it, but for Latin American countries, this can be expensive, especially those that don't have oil and gas and coal deposits. So they have to import their oil or gas in order to make electricity from it, and this is expensive. And in addition, as you all know, this is increasingly contributing to pollution and global warming. It's non-renewable. So all of us want to use more renewable energy to make electricity. So renewable energy can be obtained from wind power, from solar power, from hydropower, and from geothermal energy. And in particular, for the parts of Latin America that have volcanoes, which means they have a lot of heat under the ground, geothermal can be very important. Let's watch another video, a little bit under 3 minutes.
The Earth is hot. No, not like that. Like physically hot. With a temperature of nearly 11,000 degrees Fahrenheit, the Earth's core is hotter than the surface of the sun, and humans have found a way to safely harness a small portion of that heat energy to generate power. It's called geothermal energy. The Earth is constantly releasing its heat. Sometimes we even see it in the form of hot springs or geysers, like Old Faithful at Yellowstone National Park. Heat from the Earth is one of the most reliable, oldest forms of energy. And by old, we're talking 4.5 billion years. Ancient Romans, Chinese, and Native American cultures have used the geothermal energy for thousands of years, using hot mineral springs for bathing, cooking, and eating. So how do we capture Earth's incredible energy? There are a few ways. We can tap into the consistent temperature located just a few feet into the ground to use the Earth like a thermos, heating buildings in the winter and cooling them in the summer. Or dig deeper to access the Earth's heat. In some places in the western United States and Hawaii, this heat is shallow, less than 3 kilometers deep. But this heat is everywhere. No matter where you are on Earth, you may have to drill down a little deeper. These geothermal resources provide energy that can be used on both large and small scales. A geothermal power plant uses heat to produce steam, which turns a turbine, which drives generators and converts the power into electricity. Or the heat can be applied directly for various uses in buildings, roads, agriculture, industrial plants, and even homes. In 2019, United States geothermal power plants produced 16 billion kilowatt hours of electricity, all in the western United States. That's only a small fraction, less than 0.5% of the total U.S. utility-scale electricity generation. And there is so much potential. In fact, there is more than enough heat below the U.S. to provide all its needed energy. So why don't we use more? Geothermal is one of the least explored sources of clean energy. With such a long track record, scientists continue to work on better ways to capture and use this clean, natural, renewable resource to be able to use it anywhere in the U.S.
Hope you enjoyed that. So, what is geothermal energy? So, geothermal energy is heat or thermal energy from the Earth's interior contained in rocks and fluids. The resource that's going to be used to make electricity is hot water. And that hot water can be used to generate electrical generators. It's, as we said, abundant. Geothermal energy is abundant in volcanic regions, especially where there's a lot of water that can sink deep into the ground and be heated by magma and hot rocks. And if you're in the business, you can classify the geothermal resources as low temperature, right, less than 90 degrees centigrade or 194 Fahrenheit, moderate temperature, which is 90 to 150 or 194 to 302 degrees Fahrenheit, and high temperature, greater than 150 degrees centigrade or greater than 302 degrees Fahrenheit. And the highest temperature resources are the best for electrical power generation. So there are uses for low and moderate temperature resources. You can use them directly, say to heat a house or a greenhouse, and you can also use them to build heat pumps, places for your heat pumps. The direct use uses the heat in the water to heat buildings, greenhouses, agriculture, and resorts. All right, so here are the top geothermal energy producing countries in the world. So, the United States is the #1 geothermal energy producing country in the world, followed by Indonesia, the Philippines, Turkey, New Zealand, Mexico, Italy, Kenya, Iceland, Japan, and others. And the total amount of geothermal energy produced in the world in 2020 was all of the plants put together could generate about 15,600 megawatts. And so if you compare this to what Comanche Peak can do, this is the entire world's geothermal energy is about equivalent to 6 Comanche Peaks. So seems like a lot, but compared to everything else we need, it's not very much. All right, so as we said, there are, because there are different types of geothermal resources, high temperature, medium temperature, and low temperature, there are different ways of turning that into electricity. So the high temperature ones can be used for steam plants. Steam plants are the most cost effective. They're used when this resource is higher than 175 degrees centigrade, which is very hot water, since water boils at 100 degrees centigrade. And so this steam is generated and then expands through a turbine. So here's the production well, it comes into this tank, and then the steam is sent off to drive a turbine. And this is basically similar to the way conventional power plants work. Natural gas or coal-fired power plants use those fuels to generate the steam. Here, you're taking the steam right out of the earth. Now, you don't just vent the steam after it's come out of the turbine into the atmosphere. You condense it because you need more water down in the well. So you'll condense it and you'll re-inject that water back in the ground so that you set up a system. In contrast to steam plants are binary plants. And so binary plants, they take the heat from lower temperature geothermal resources and they use it to heat up volatile working fluids. So usually it's some kind of a volatile hydrocarbon, and it'll vaporize into gas at a much lower temperature than water turns to steam. And so it can be used to generate on electricity, but it's much less powerful than these steam plants. And that working fluid is in a closed system. It's condensed and reused. It's not injected into the earth, but it's just reused in this cycle. All right, so this is what provides the heat for geothermal systems. This is an arc volcano, and arc volcano, here you've got a volcano with an eruption plume. You know, down we're looking at deep into the crust. The crust here is only about 25 kilometers thick. You've got a circulating mantle, and heat in the form of magmas is coming out of it, and these things move up through the crust. And up in here, where if there's water, that water can get heated, and that can be used to generate steam and drive a geothermal power plant. So the best geothermal resources are in water-rich regions near active and dormant volcanoes. So here we've got a volcano, some magma down there. There's hot rocks here. Lots of water coming in, say, from a lake. Becomes groundwater, starts off cold, but as it flows towards the hot rocks and the magma, it gets heated, and then it comes back to the surface in hopefully a geothermal field. That's what you're looking for in order to build a geothermal plant. So, as we said, the best geothermal resources are near active and dormant volcanoes. We know there's 382 Latin American volcanoes. They're all here on the west side, except for in the Caribbean, up here in the east. But Brazil doesn't have any. Paraguay, you know, they're over here in Mexico, Central America, Colombia, Ecuador, southern Peru, Chile, Argentina, and down like that. And that's where the geothermal energy plants, there are 17 of them now. And you'll notice a concentration in Central America, which we're going to end up talking about quite a bit. So, as you recall, plate tectonics tells us why volcanoes are where they are. We're going to talk more about this when we get to the hazards later in the course. And in the plate tectonic scheme, the volcanoes in Mexico, Central America, the Andes and Lesser Antilles, these are all related to subduction of oceanic lithosphere in a subduction zone, and these volcanoes form above that. We've talked about that before. Okay, here's a very simplified drawing. Here's an overriding plate, the subducting plate, and there's a bunch of earthquakes in here. We'll talk about that too later, not in this lecture. A region of melting in the mantle, and then the volcanoes up here, and then this is where you're going to be hoping there's some geothermal resources. Next slide. All right, and this is true of the entire circum-Pacific Ring of Fire, all the way up through Western North America, the Aleutians, Pacific Russia, Japan, Philippines, Indonesia, and down to New Zealand. And these are very similar to the geothermal regions. This is the Pacific Rim of Fire geothermal region, but then there are many others. So Iceland is in here, East Africa has some. There's a number of other places where geothermal resources exist, but all of these around the Pacific, including in Latin America, are related to the subduction of the Pacific plate. All right. Okay, so here are the active volcanoes of Latin America. There are more than 110 with historical eruptions. That means they're very active. If they've erupted since people have been here, they've erupted in the last, certainly last 15,000 years, but when we talk about history where people write down stuff, that basically starts with the Spanish. So we're talking about things that have erupted in the last 500 years. Next. All right, so how do we find geothermal resources? So we have to find hot areas with a lot of circulating water and drill down into the hottest regions. And so the way we talk about good places and bad places is using this term called the temperature gradient or the geothermal gradient. It's the same thing. So here we are going down in the crust 3,000 feet, about half a mile. And then this dashed line is the typical geothermal gradient. goes down about, several degrees per 100 feet or so. And this is an example of a geothermal gradient in a region where you've got good potential for geothermal energy, because you can see it's, especially down here, it's much hotter. So at the bottom of the hole it was 265 degrees centigrade. If you've got good water flow through that, that would be a very attractive place to start extracting geothermal energy. So this is a temperature map of the state of Texas, and what it's showing you is how deep do you have to go to what's called moderate temperature resources, on the order of 90 or 100 degrees. And you can see, this is 2,400 feet, or almost, that's 5 miles, and this one is 8,000 feet, or a mile and a half. So you can see that in East Texas is got much more geothermal resources than West Texas, which has got, you have to drill deeper to get to the same temperature. All right, so let's just talk about how we generate our electricity here in Texas. So this was 2019. This is, we talked about what was the total amount of energy that Texas used. This is what we use to make it. So about 40%, all of this and all of this is made by burning natural gas. And then another 20% is made by burning coal. Interestingly enough, about another 20% of Texas electricity is made by wind energy. Not very much solar yet, fair amount of nuclear, and almost no hydro. But you'll notice there's no geothermal energy that's contributing to the state of Texas. And in that previous map, we saw why. I mean, Texas doesn't have any volcanoes, so it's very unlikely to have any significant geothermal resources. All right, so here's how we do it. Once we decide we've got a good place, we have a production well where we take the hot water up and we use it to drive the turbines and generate electricity, which goes off to the city. And then we condense the steam. You see these cooling towers where the steam is cooling, the water is cooling, and then we pump that back in the ground in an injection well. So here is a turbine generator. So the steam is coming in here. These blades, they're pushing on these blades are rotating, and the electricity is produced in here by spinning coiled wires in a magnetic field. So the benefits of geothermal energy are remarkable. First of all, it provides a clean and safe energy which uses very little land. It's renewable and sustainable if you manage the resource well and re-inject. It generates continuous, reliable base load power. That means they're not subject to whether the wind blows or the sun shines like wind and solar are, but it stays hot and generates about the same amount of steam all of the time. That's called base load. Very important to be able to provide the base load. It conserves fossil fuels and contributes to diversity in energy sources. Right now in 2022, we're feeling the pinch of rising energy prices, fossil fuel prices. So there's no change in the cost of geothermal energy. The costs are sort of fixed, whereas fossil fuels are subject to changes in the marketplace. And it avoids importing with loss of currency and benefits local economies by providing jobs as well as electricity. And it can be modularized. You can have small geothermal energy plants or large ones, so you can have different sized plants and provide energy to remote sites. All right. Let's talk about the geothermal plant that generates the most electricity in the world. That is in California. It's called the Geysers. And in 2019, it generated about 600 megawatts, about a quarter of what Comanche Peak generates, but it's enough to supply a city of over 1 million people with electricity. In Latin America, the largest geothermal plant is Cerro Prieto in northwest Mexico. And it has an 821 megawatt capacity, but this is not the capacity of geysers. This is its average generation. This is its capacity, which you rarely meet the capacity of a plant. So here's Cerro Prieto in a map of Mexico, and here are several other geothermal energy plants in Mexico. Los Tres Vergenes, Domo San Pedro, Cerritos Colorados, Los Humeros, and Los Azufres. There we go. That's Los Humeros. So Cerro Prieto, as we said, is number 1. Los Azufres is number 2. Los Humeros is number 3. Los Tres Vergenes is number 4. And Domo San Pedro is last in terms of electricity production. So here's the Cerro Prieto field in Baja California. It's right here. That's the Salton Sea. That's the California-Mexico borderline. This is Arizona. That's Colorado River coming in. And so you've got a lot of water. You're in this sort of delta of the Colorado River, and you've got this mid-ocean ridge spreading center that's coming up through here. So you've got a lot of hot rocks associated with seafloor spreading underneath these sediments. This Cerro Prieto is the largest complex of geothermal power plants in terms of overall size in the world, and the second largest in terms of energy output. And just to show you a little bit more about the geology there, this is basically the same map. There's the U.S.-Mexico, California-Mexico border, Arizona, Colorado River, Gulf of California. These are these spreading segments in here. So these are transform faults. We talked about those. This part is moving that way relative to North America. And here you've got igneous rocks coming up every once in a while. And this segment in here is the igneous rocks in there are providing the heat to power the Cerro Prieto field. Okay, so this shows it a little bit more detailed. Now we're seeing the faults. This is going to become the San Andreas Fault up here. And these are little segments of spreading center that's buried underneath the sediments. Here's another one here. So the United States also has some geothermal energy plants up on top of these hot rocks. And these are the ones where Cerro Prieto is. This is a view from space. And here you can see this. This is sort of a cooling pond related to the geothermal field. And the 3 thermal generating plants are below and to the right of these ponds. Maybe right there. Another one there. Oh, maybe that's the 3rd one. All right, so there's a lot more geothermal potential in Mexico. It has over 1,500 hot springs. One Mexican state is named Aguas Calientes, which means hot water, so that's a good sign. There's lots of direct use of geothermal energy in Mexico, including industrial laundries, refrigeration, district greenhouse heating, fruit and wood drying. And the Mexican state utility has awarded exploration permits on 13 geothermal zones scattered in several states, and 7 private companies are exploring these additional zones under their own permits. And geothermal energy produced 1.3% of Mexican electricity in 2020. Not a lot, but it's definitely moving in the direction we want to go. All right, just to show you, plenty of volcanoes in Mexico. This is probably the most famous Mexican volcano, Popocatépetl, just outside of Mexico City. All right, now there are lots of volcanoes in the Lesser Antilles too. There are 19 potentially active volcanoes in the Lesser Antilles, so that's 200 kilometers, 120 miles. So what are we looking at here? Like 800 kilometers from north to south, or 500 miles. There's a lot of little islands in here. 6 volcanoes have erupted over the last 400 years. 11 volcanoes have had severe earthquake swarms, which is a sign of magma moving up the conduit. Have surface hydrothermal activity associated with them, which means they've got fluids that are moving around, and have volcanic deposits that have been dated within the last 10,000 years. And so the thermal energy of these volcanic islands makes them a good potential target for geothermal exploration. Now the Andes is also a good place to look, because there's lots of Andes volcanoes, several high temperature geothermal systems you can see from hot springs and things. There is a small geothermal plant in Argentina, but only less than 1 megawatt. Right? Remember, one plant at Comanche Peak is 1,200 megawatts. But there's remarkably little use of the geothermal potential in South America yet. That's interesting. So, which part of Latin America really goes to town with geothermal energy? It's the countries of Central America. And this gives us a chance to visit Central America and talk about them. So here's Mexico up there. And then next country to the southeast is Guatemala, then Honduras, El Salvador, Nicaragua, Costa Rica, and Panama. And you can see where the volcanoes are. They're in Guatemala, El Salvador, Nicaragua, Costa Rica, and those are the ones that are going to have the geothermal energy. So here is an example of a Central American volcano. This is Arenal in Costa Rica, very spectacular volcano. You can see it erupting, and a very nice place to visit if you ever go to Central America. Hopefully it'll be erupting for you. All right, so now let's look at geothermal energy just in Central America. So these are the countries: Mexico, Costa Rica, Nicaragua, El Salvador. Now Ecuador's in there, it's in South America obviously, Guatemala, Honduras, Panama. Now this is how much electricity capacity exists in geothermal. So Mexico obviously is far and away the most, but as we said, it only generates about 1.3% of its electricity that way, and that's because Mexico generates a very large amount of electricity for its large population. Whereas these other countries, Costa Rica, Nicaragua, El Salvador, Guatemala, they are smaller countries, and so much smaller amounts of electricity generation can make up a much larger percent of their total electrical needs. Look at Nicaragua. Nicaragua generates maybe 20% of what Mexico does, but that's 25% of its electricity needs. That's tremendous. El Salvador, about 15% of its electricity needs. Costa Rica, almost 14%. So, the fact that these countries have small populations, they're really going to town in terms of exploiting their geothermal energy. And it's a very good sign, because these are largely poor countries, and anything they can do to reduce the amount of oil and gas they have to buy leaves more money for the country and produce jobs for people in the country is a good thing. All right, so let's just talk about the 7 countries of Central America in general. So there's 7 of them, Guatemala is 1, El Salvador is 2, Honduras is 3, Nicaragua is 4, Costa Rica is 5, Panama is 6, and don't forget Belize. Belize is on the east coast. It doesn't have any volcanoes, but here are the ones that have the significant amounts of geothermal energy. Guatemala has 53 megawatts of capacity, El Salvador has 205, Nicaragua is 149, Costa Rica 305, Those are still added up together much less than one Comanche Peak power plant, but still they're generating very significant percentages of their total electrical needs. So now let's rank the nations not by the amount of electricity they make with geothermal, but by the percentage of the national energy that's produced by geothermal energy. So these countries in red are Latin American countries. So Kenya is number one with 38% of its electricity generated by geothermal. Iceland, 30%. Philippines, 27%. Then El Salvador, 25%. New Zealand, Costa Rica, Nicaragua, Indonesia, Guatemala, and Mexico. That's actually a slightly different number than I was telling you, but it's small. So 5 of the 10 top producers of geothermal energy by percentage of the national energy use are in Latin America. All right, so let's just talk a little bit more generally about the 7 nations of Central America. So if we put them all together, they would make a country that was about 3/4 the size of Texas. And they have 49 million inhabitants compared to our 30, so about 170% of the Texas population in these 7 countries. So let's start off with Belize. It's a very small country, about 3% the size of Texas, with about a 250,000 people, relatively low per capita GDP, no active volcanoes, no geothermal electricity. Costa Rica is a little bit bigger. It's about 7% the size of Texas, $3.8 million people, with a much higher GDP of $8,500 per capita. It's the wealthiest nation in Central America. It has several active volcanoes that generate about 14% of its electricity. El Salvador is a small country about the size of Belize, about 3% the size of Texas, with many more people, 6.5 million. Per capita GDP about $4,600, with several active volcanoes, and it generates about 20% of its electricity from geothermal energy. Here we're looking at 2 particularly interesting geothermal energy sites. One is Ahuachapan, which is up here, and the other one is at Berlin here. And this is a 95 and 56 megawatt plant in Berlin. So let's watch a short video about the Ahuachapan plant.
El Salvador is a small Central American country totally devoid of fossil fuels. For decades, the pioneering Salvadorians have been using the heat of the earth to produce renewable geothermal energy to power their nation. Now, as the economy shifts into high gear in this densely populated country, scientists and engineers are under pressure to produce more and more energy. They are on a mission to tap the vast reserves of geothermal power that lie buried around the country's network of volcanoes. To support El Salvador in its pursuit of green energy, the United Nations University Geothermal Training Program in Iceland has trained generations of energy experts, providing them with cutting-edge geothermal knowledge and skills. 3 graduates of this innovative program are leading the quest to find solutions to their country's energy needs. Will they be able to keep the lights on in El Salvador by using the heat of the earth? In western El Salvador, the geothermal power plant of Ahuachapan is one of the first of its kind in the world and has been producing renewable energy for more than 35 years. Using superheated steam from deep under the Earth's surface, the power plant produces enough electricity to power more than 300,000 homes. Even during the brutal civil war in the 1980s, when major infrastructure was destroyed and energy production was disrupted in most of the country, this power plant continued to produce energy, accounting at times for up to 40% of the electricity generated in El Salvador. Being so important for the country, the plant must be kept in good working condition. As a maintenance engineer, Godofredo Lopez is in charge of keeping the plant running.
En El Salvador, la geotermia es una generación base por sus costos de producción.
Today, a sudden emergency threatens to paralyze the plant. The power plant is reporting a malfunction, and the engineers are checking all electrical and mechanical systems to find the problem.
Esas paradas no programadas son las que resultan caras para la empresa, así como también reducen la disponibilidad de máquinas.
If they cannot fix the problem quickly, they will have to stop producing electricity. To continue to meet electricity demands, a diesel plant somewhere else in the country will have to compensate with increased production that relies on burning expensive and polluting fossil fuels.
Para nosotros es bien importante mantener esos tiempos de mantenimiento bien cortos para evitar así que el consumidor final, el pueblo, el país como tal, reciba el impacto de estar pagando la energía más cara.
They find a mechanical problem and are quick to get down to fix it. But keeping things running here is not only about the power plant itself. It is also about maintaining a constant flow of the superheated steam that powers the plant. Thermal fluid specialist Edwin Milare analyzes the chemistry of the steam flowing from the geothermal wells and nearby fumaroles to understand what is happening in the underground reservoir as they extract steam for energy production.
Entonces, si en un dado caso se sube la concentración de los gases, eso sirve como un indicador al área de geoquímica de que algún proceso está siendo alterado debido a la extracción.
If they extract steam too quickly, there could be a catastrophic drop in heat and pressure in the reservoir, and multi-million-dollar geothermal wells could go out of service, leaving the plant without the steam it needs to produce electricity.
La energía geotérmica siempre ha sido catalogada dentro de la energía renovable. Más sin embargo, esa extracción hay ciertos límites, ¿no?, para ella, y es lo que nosotros evaluamos mediante el monitoreo químico. Si esa extracción permite ser sostenible la explotación del recurso.
Estimates project that the Ahuachapan and Berlin geothermal fields will ensure between 25 to 30 additional years of production. They take the samples to the lab for analysis. It is one of the most advanced geothermal energy labs in Latin America. Just like Edwin analyzes the chemistry of the thermal fluids, other scientists analyze rocks and minerals contained in the core samples they obtain while drilling. Based on the findings from Edwin and his team, important decisions are made about exploring new reservoirs, drilling expensive new wells, and regulating the extraction of steam.
Estamos produciendo energía que mueve un país y a la vez no lo estamos contaminando, ¿no? Entonces eso te llena, ¿no?, te satisface.
Hope you enjoyed that. So now just northwest of El Salvador is Guatemala, which is a larger country, about 16% the size of Texas, with almost half of the number of people, a low GDP, 3,700, with several active volcanoes, and generates about 4% of its electricity from geothermal energy. Honduras is about 16% the size of Texas, 6.5 million people, very low per capita GDP, but it has no volcanoes, so no electricity is being generated by geothermal. Nicaragua, it's about almost 20% the size of Texas, 5 million people, $2,500 per capita GDP, and several active volcanoes, and generates about 10% of the electricity from geothermal. So here's an example. This is, you see these big lakes in Nicaragua. Some of them even have these chains of volcanoes here related to subduction of the oceanic plate underneath it. And you've got these lakes in here. So this combination of active volcanoes and lakes, here you can see one very nicely, a big volcano built out in this lake. You've got hot rocks at depth, and you've got water that can seep in there. It's a very good situation for geothermal energy. And finally, Panama. It's about 10% the size of Texas with almost 3 million people, $5,900 per capita GDP, no active volcanoes, and of course no electricity generated from geothermal. So if you're going to go into the business of geothermal energy, the best thing to do is find your volcanoes and look around them. So it's kind of puzzling. Central America obviously has lots of geothermal energy, but South America does not, even though there must be as much geothermal research in South America as there is in Central America. Why is that? So the reality is that many of these other South American nations with geothermal potential have other options for generating electricity. So hydrocarbons, Argentina's got that. They can burn that. Now, Brazil doesn't have any volcanoes, so it probably couldn't generate any geothermal energy, but as you'll find out when we talk about oil and gas in Latin America, it's got plenty of oil, it can burn that. Colombia, sort of similar. It's got volcanoes, but it's got oil. Ecuador and Peru, they like to burn hydrocarbons. But there is a real opportunity there for building up the geothermal energy of those countries. And then some other ones, they have a lot of mountains and rivers, and they can generate hydropower. That includes Argentina, Colombia, Ecuador, Peru, Chile, and Bolivia. And they have these relationships. So Argentina sells Chile natural gas cheaply, and Chile uses that to produce electricity at about 5 cents per kilowatt hour. And in general, geothermal is more expensive than that. It's more like 5 to up to 8 cents per kilowatt hour. And so the cheap source of energy is going to win. Now, maybe things will change as prices rise for fossil fuels, but that we'll have to wait and see. All right, so one of the interesting things is this CPAC project. This is the system of interconnecting the electricity for the countries of Central America. I'm not even going to try to pronounce that. But basically, this is an electrical grid that's connecting these countries so that each country can have some confidence that there'll always be electricity there. This is a high voltage power line that's carrying the electricity around. They completed the 1,800 kilometer long transmission line with 300 megawatt capacity. It's going to be upgraded to 600 megawatts, and that will provide some integration of the Central American electricity markets. Now, an interesting thing is happening that is going to be a competition for geothermal energy. So this is Mexico here, and Guatemala, Honduras, El Salvador. And just offshore is very rich natural gas fields in the Gulf of Mexico. And so they're planning a natural gas pipeline to bring natural gas down and then into Guatemala, El Salvador, and Nicaragua. And depending on what the prices are for natural gas, that is going to be competition for geothermal energy. Obviously, if the investors see that the prospects for natural gas being expensive, they're going to invest more in geothermal. If, on the other hand, they see that natural gas is going to be cheap, or they think it's going to be cheap, they'll invest more in natural gas plants. So we're just going to have to wait and see if this pipeline actually develops, and then what's the result of it. So I hope you enjoyed that. Geothermal energy is a very exciting area of opportunity. And in the next lecture, we'll learn more about energy through oil and gas. So thanks.